Hello and welcome to Mr. Tompkins EdTech. This series of videos provides work solutions for the GCSE Maths topic test produced by AQA. This video is Basic Probability. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button, as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. Before we get started, I'm just going to show the blank question paper. So if you don't have a copy, you can now pause it and have a go at the questions first. And then once you're finished, you can start again and look at the answers. Okay. Question 1. Temi rolls 2 fair 6-sided dice. The two numbers rolled are then added to give a total. Work out the probability that the total is a single-digit prime number. So when you're combining the outcomes of two separate events like this, a good way of arranging it is in a possibility space, which is like a little bit like a table where you put all the different values in. So you've got two different dice roll. You can get 1, 2, 3, 4, 5, or 6 on one dice, and you can get 1, 2, 3, 4, 5, 6 on the other. Okay, and then what we need to do is then add those two results together, don't we? We're told here that the two numbers are added to give the total. So inside the possibility space, I'm going to add the two scores together and write down the sum of those two scores. So 1 and 1 adds up to 2, 1 and 2 adds up to 3, and so on. So 2 plus 1 is 2 is 3, sorry. 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, 6, 7, 8, 3 plus 1 is 4, 5, 6, 7, 8, 9. You can see it kind of makes a nice pattern. So after a little bit, you should probably be able to fill this in without too much thought. Okay, so there are 6 rows of 6, so that means there are 36 different outcomes altogether. Now we want the single digit prime numbers. They're the outcomes we're interested in. Now the single digit prime numbers are the numbers 2, 3, 5, or 7. So they're the outcomes that we're looking for. So we can look at our possibility space and then count how many entries we've got of those 4 different outcomes. So I've got a 2 here, I've got a 3 here, and a 3 here. I've got 5, 5, 5, and 5, and I've got 7, 7, 7, 7, 7, and 7. So altogether I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different outcomes, which are single digit prime numbers. Now any probability event has an equation: successful outcomes divided by total outcomes. That's how you work out probability. So here we said there were 36 separate outcomes, each of the entries of our possibility space, and 13 of those are single digit prime numbers. So the outcome is 13 over 36. That's the probability. Question 2. 84 people take a driving test. A quarter are men. For the men, the ratio to pass to fail is in the ratio of 5 to 2. The number of women who pass is double the number of women who fail. Complete the frequency tree. Okay, so we've got some spaces here that we need to fill up. Now with the frequency tree, the two pairs of numbers that leads up to another pair need to add together to give you that total. So the number of men plus the number of women must be 84, and the number of men who pass plus the number of men who fail needs to add up to the number of men. And then finally, the number of women who pass plus the number of women who fail must add up to the number of women there are altogether. Okay, so we got some information up here to help us work out what those values are. Okay, so let's take it from the top then. So it says 84 people are taking the driving test. That's already been added to the diagram. That's the top circle. Okay, now the next piece of information says 1/4 are men. Okay, so if we divide or multiply 84 by a quarter, same as dividing it by 4, what's that then? So 84 multiplied by a quarter, or 84 divided by 4. Well, 4 goes into 80 20 times, plus 1 is 21, isn't it? So there must be 21 men. Okay, so that bit there tells us that there are 21 men, so we can write that in this box. So if there are 21 men, there must be 84 subtract 21 women then, mustn't there? Because these two numbers add up to 84. So 84 subtract 21 is going to give me 63. So 63 women and 21 men. Okay, what's the next piece of information? I'm told that for men, the ratio of pass to fail is in the ratio of 5 to 2. Okay, so for every 5 men who passed, 2 failed. Okay, and we've got 21 men altogether. So basically it's like sharing in a ratio, isn't it? So if I've got 21 that I want to share in the ratio of 5 to 2, we have to take our two numbers in the ratio, add them together. 5 plus 2 is equal to 7. And then I can divide that into my total. So 21 divided by 7 is going to be 3. So then taking my ratio of 5 to 2 and scaling it up by a factor of 3, I'm going to get 15 to 6. Okay, so 15 men must have passed and 6 men must have failed. So I can write those numbers in now as well. So 15 and 6. Now you should just double check they add up to 21. Yes, they do. 15 plus 6 is 21. Okay, finally it says the number of women who pass is double the number of women who fail. So rewriting that as a ratio then. So the ratio of pass to fail, twice as many pass as fail. So that's a ratio of 2 to 1. Okay, now we've got 63 women, haven't we? And if we're going to divide that into a ratio of 2 to 1, 2 plus 1 is 3. 63 divided by 3. 3 is going to 60 20 times. Plus 1 is 21, isn't it? So that's also 21. So multiplying that by 21, 2 to 1 in the ratio of, well, multiply that by a factor of 21. I'm going to get 42 women passed and 21 failed. 42 plus 21 is equal to 63, so it fits. So 42 go here and 21 go there. Okay, I think we're done. Part 2b says one of the people is chosen at random. Work out the probability that is a woman who passes. Give your answer as a fraction in its simplest form. Okay, so remember the probability of an event happening is successful outcomes divided by total outcomes. So here, the probability that it's a woman who passes, That's going to be, well, how many different outcomes are there altogether? One person is chosen at random. Now you remember from the diagram there were 84 people altogether. So the total number of different outcomes is I could pick someone in 84 different ways. So that's the 84 on the bottom. Here, successful outcomes is going to be the number of women who pass. So from the diagram, pass is 42, isn't it? So probability of women who pass is 42 out of 84. Now you might see that that cancels down to a half. Now weirdly, from any probability question I've ever seen in an exam, you never get any credit for cancelling down fractions. So unless it's blatantly obvious or you've got your calculator with you, then just leave it as the original fraction you've got. Otherwise you might make a mistake cancelling it down, but here I'm quite confident that it's a half. So I'm going to write my answer as a half. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 3. A pond had 60 fish. 27 were carp and the rest were tench. 10 fish were added. The probability that the fish picked at random is a carp is now 1/2. How many tench were added? Okay, so I've got a pond with 60 fish in. 27 were carp. So let's just sketch that a little bit like the previous question. 60 people all together, and I've got 27, which is carp, and so what's left then? That's got to be 33 tench then to start with. Okay, so then we need to add 10 fish. It's going to add 10 to this, and now it's going to be a probability of half. So if it's a probability of a half, it means that half the fish must be now carp. Okay, so if I had 60 fish to start with and I add 10, I've now got 70 fish. Half of 70 is going to be 35. Okay, so I need to have 35 carp and 35 tench. So the probability of picking a carp is going to be 35 out of 70, which is the same thing as a half. So how many carp do I need to add, and how many tench do I need to add? Okay, so to make the number of carp equal to 35, I will need to have had 8 carp, and I should have added 2 tench then to make 10 added altogether, and a total of 35 of each. So how many tench were added? It's going to be 2 tench. Question 4. A box contains counters that are red, blue, yellow or green, and the table shows some of the information about picking a counter out. So we know the probabilities of picking blue, yellow and green. We've not been given the red one. Now we're told that there are 40 blue counters. How many red counters are there? Right, okay, so first off, let's see if we can work out what the probability of selecting a red was. We're going to be using the rule of completeness, which basically means that if you add all the probabilities of obtaining a different outcome in an event, it should add up to 1, because you are certain to get one of those outcomes. So because of the rule of completeness, these probabilities, let's call the number or the probability for red to be x, then all those 4 numbers, x plus 0.25 plus 0.35 plus 0.3 should add up to 1. Okay, well, what is 0.25 plus 0.35 plus 0.3? 0.25 and 0.35 is 0.6, plus 0.3 is 0.9, isn't it? So that's x plus 0.9 is equal to 1, making x equal to 0.1. Okay, So we know then the probability of getting red must be 0.1. So if there are 40 blue counters altogether, and we know the probability of obtaining the blue is 0.25, we should be able to work out the number of counters altogether. So probability of blue we know is 0.25, which as a fraction, can't write 5 today, 0.25 as a fraction is a quarter, isn't it? Remember, probability is successful outcomes over total outcomes. So if we've got 40 blue counters, this number at the top must be 40. So what's the number at the bottom? Well, if I've multiplied this by 40, then I need to multiply this by 40 as well. 4 times 40 is 160. So there must be 160 counters altogether then. Okay, so 160 counters. And the probability of success is 1 in 10 or 0.1. So how many red counters are there? So the probability of red is going to be 0.1, which is 1 over 10, and that's the same thing as something over 160. So to get from 10 to 160, I have to multiply by 16, wouldn't I? So if I do the same to the top, it means there must be 16 red counters out of a total of 160 counters altogether. So I'm saying then there are 16 red counters altogether. Question 5. 120 students have maths or science next lesson. There are 12 more boys than girls altogether. The ratio of maths to science is 2 to 3. Half as many girls have maths as have science, and we need to complete the table. Okay, so this is fairly common for stars of questions for the new syllabus. They like to mix different topics together, so you're not rarely going to get a probability question on its own. They're mixing it in here with knowledge about ratio and so on. So let's see if we can work it out. Okay, let's just take this first statement here then. There are 12 more boys than girls altogether. Okay, so there are 120 students and there are 12 more boys than girls. Okay, so if you divide 120 by 2, that's 60-60, isn't it? So if there were equal numbers of boys and girls, and you divide 120 divided by 2, you're going to get 60 boys and 60 girls. No, that's not quite right, because we want 12 more boys than girls. Okay, so I'm going to divide 12 by 2, it gives me 6. If I make them have 6 more boys and 6 less girls, so then the difference between 66 and 54 is 12. So there must be 66 boys and 54 girls. So adding that information to the table, there are 66 boys and there must be 54 girls, which gives us our total of 120. Okay, so we've done the first line. Okay, the ratio of maths to science, is 2 to 3. So for every 2 maths students, there must be 3 science students. So again, let's just do our dividing by a ratio thing. So I've got 120 students, and I want to divide it up in a ratio of 2 to 3. 2 plus 3 is equal to 5. 120 divided by 5, what does that give me? 5s into 120 go 24 times. So scaling up this ratio here by a factor of 24. 2 24s are 48, and 3 24s are 3 20s are 60. 3 4s are 12, must be 72. Just double check, 48 plus 72 does equal 120, so it looks good. So 48 math students, 72 science students. So put that in as well. 48 math students, 72 science students. Okay, then finally we've got half as many girls have maths as have science. Half as many girls have maths as have science. Okay, half as many girls have maths as have science. Okay, so if half as many girls have maths as have science, then the ratio of maths to science has got to be in the ratio of 1 to 2. So half as many girls have maths as have science. So twice as many girls do science as do maths. Okay, so again, if you remember, we've got 54 girls altogether from the table. So if I take 54 and I divide it in a ratio of 1 to 2, I've got to take 54 and divide it. Well, 1 plus 2 is 3. So let's divide 54 by 3 then. 54 divided by 3 is 18. That's equal to 18. So then multiplying back my ratio of 1 to 2 by 18, what am I going to get? Well, 1 times 18 is 18. And 2 times 18 is 36. So there must be 18 girls doing maths and 36 girls doing science. Okay, so we've got no more information up here. So how can we work out the last part? Well, I know altogether there are 48 students doing maths. So if 18 of those are girls, then the remainder 30 must be boys. Similarly, if I know that 72 students altogether do science, and I know 36 of those are girls, then the other half, 36, must be boys. Okay, and I just want to double check this way. Does 30 plus 36 equal to 66? Yes, it does. So I think that's now complete. Okay. All done. So let's move on to part B. It says, because we haven't actually done any probability yet, a student is chosen at random. Finally, one marker which is about probability, rest about number. Work out the probability that it's a boy who has maths. So again, the probability of any event is equal to successful outcomes divided by total outcomes. Okay, so we are choosing a student at random from all of these students. So in total, there were 120 students, weren't there? Okay, so the probability of a boy who has maths is the total number of students I can pick from. Now, from the table, how many boys like maths? It's that one there, isn't it? Boys who like maths or have maths is 30. So I'm going to write that on the top, 30 out of 120. Now I can see pretty immediately that they're going to cancel. 3 out of 12 is the same thing as 1 out of 4. Okay, but like I said earlier, you don't get any extra credit for cancelling down. This is a 1 mark question, and you would have gained the mark by writing 30 out of 120. So just take care when cancelling down fractions. This bit here will earn you no extra credit. So if you get it wrong, you're just going to lose that 1 mark you've already gained. So just take care. If you're not sure about cancelling it down, just leave your original answer. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.